Have you ever wondered how a tiny atom can produce so much energy to power entire cities? Well, let's dive into the fascinating world of nuclear power to find out. In the heart of every atom lies an incredible source of energy. This energy, when unleashed, has the capacity to power entire cities, fuel spacecraft, and even forge weapons. The driving force behind this phenomenal power is nuclear reactions, where the nucleus of an atom is manipulated to release energy. But how do we coax these atoms into releasing their energy? The answer lies in the elements uranium and plutonium. These heavy metals have large, unstable nuclei that are perfect for nuclear reactions. When a neutron strikes the nucleus of a uranium or plutonium atom, the nucleus splits into two smaller nuclei, releasing a tremendous amount of energy in the process. This process is known as nuclear fission. The discovery of nuclear fission in the late 1930s opened the door to a new era of energy production. Initially, the immense power of the atom was harnessed for destructive purposes, leading to the creation of the atomic bomb. However, in the decades that followed, scientists and engineers found ways to harness this power for more constructive uses. They built nuclear power plants that use controlled nuclear reactions to generate electricity. Today, nuclear power plants collectively generate about 10% of the world's electricity, providing a significant portion of the power that lights up our homes, powers our factories, and charges our electric vehicles. Nuclear power, like all forms of energy, has its advantages and drawbacks. It's a low-carbon source of energy, which is great for fighting climate change, but it also produces radioactive waste and poses risks if not managed correctly. As we move forward, it's crucial to balance these factors to make the best use of this powerful energy source. So, the power of an atom harnessed correctly can light up our lives, quite literally, and that's just the beginning of the story. Stay tuned as we delve deeper into the mechanics of nuclear power, its pros and cons, its future, and its impact on our world. But how exactly does this atomic energy become electricity that powers our homes, schools, and offices? Well, let's dive right in and uncover the mechanics behind nuclear power. Imagine an atom, a tiny constituent of matter no bigger than a speck of dust. This atom, specifically a heavy one like uranium or plutonium, holds a vast amount of energy in its nucleus, the atom's center. This is where nuclear fission comes into play. Fission is the process where the nucleus of an atom is split into two smaller fragments. This split releases a tremendous amount of energy in the form of heat, but it's not just a single atom that splits. Once an atom splits, it releases additional neutrons, and these neutrons go on to split more atoms, creating a chain reaction. It's like a domino effect, but on an atomic level. Each split releases more energy, and the process continues, generating a constant stream of heat. Now, how does this heat energy become electricity? The answer lies in a process that's been used for centuries, turning water into steam. The heat generated by the nuclear fission is used to heat water. This water, under high pressure, transforms into steam. And here's where the magic happens. The steam drives a turbine, a machine with thousands of blades that spin when hit by the steam. As the turbine spins, it turns a generator, and this generator, thanks to the wonders of electromagnetic induction, produces electricity. This electricity is then sent through transformers to increase its voltage, enabling it to travel long distances through power lines. And voila, this is how the energy locked within an atom's nucleus ends up powering the lights in your home, the computer in your school, or the coffee machine in your office. So the journey of nuclear power is from the heart of an atom to the heart of our cities. The process may seem complex, but it's this intricate dance of atoms and energy that keeps our world running. Like everything else in life, nuclear power has its good sides and bad sides, but what are they? Let's start with the positives. First off, nuclear power is incredibly efficient. The energy produced by a small amount of uranium, the fuel most commonly used in nuclear reactors, is staggeringly high. To put it into perspective, 1 kilogram of uranium can produce as much energy as about 4,000 tons of coal. That's a lot of energy from a little material. Secondly, nuclear power is a low-carbon energy source. Unlike fossil fuels, nuclear power plants don't emit harmful greenhouse gases like carbon dioxide or methane. In a world grappling with the effects of climate change, this is a major plus. Nuclear power could play a key role in decarbonizing our energy systems and helping us meet our climate goals, but there's no such thing as a free lunch, right? So let's delve into the downsides. One of the main concerns about nuclear power is the risk of accidents. While these are rare, when they do occur, they can be catastrophic, as we've seen with incidents like Chernobyl and Fukushima. Another significant concern is the issue of nuclear waste. Nuclear power generates long-lived radioactive waste that must be managed and stored for thousands of years. It's a complex and costly process, and despite decades of research, we still don't have a foolproof solution. Lastly, there's the issue of nuclear weapons proliferation. The technology and materials used in nuclear power can also be used to produce nuclear weapons. This dual-use nature of nuclear technology poses a significant security challenge. So nuclear power is a double-edged sword with immense potential but also significant risks. The question remains, can we harness its power while effectively managing its risks? That's a debate for another time. For now, we've covered the basics of nuclear power's pros and cons. With the world looking for cleaner, more sustainable energy sources, what role does nuclear power play in our future? As we delve into the potential future of nuclear power, we're greeted with innovative advancements and promising prospects. These include the development of fusion power and the design of smaller, safer reactors. Fusion power, a technology still in its infancy, holds immense potential. Unlike fission, which splits heavy atoms to release energy and produces harmful waste, fusion combines light atoms such as hydrogen. This process, similar to what happens in the heart of our sun, promises a virtually limitless supply of power with minimal waste. The challenge lies in replicating these stellar conditions on Earth, but with ongoing global research, we could witness a fusion-powered future sooner than we think. On the other hand, we have the advent of smaller, safer nuclear reactors. These reactors, aptly named Small Modular Reactors or SMRs, are designed to be cost-effective and flexible. They can be manufactured off-site and transported to their destination, reducing construction time and costs. More importantly, their inherent safety features, such as passive cooling systems, make them less prone to accidents, addressing one of the biggest concerns associated with nuclear power. But let's not forget the crucial role nuclear power can play in combating climate change. The Intergovernmental Panel on Climate Change suggests that nuclear energy, alongside renewable sources, can contribute significantly to limiting global warming to 1.5 degrees Celsius. This is because nuclear power produces electricity without emitting carbon dioxide, the leading greenhouse gas responsible for global warming. So, as we look to the future, we see a landscape where nuclear power, guided by technological advancements and driven by the urgency of climate change, could play a pivotal role. It's a future where the power of the atom, harnessed responsibly and innovatively, could provide us with a sustainable and clean energy source. So, nuclear power, if harnessed responsibly, could be a key player in our sustainable future. Nuclear power has shaped our world in more ways than one. But what impact does it truly have on our lives and our planet? It's a question that invites a deep dive into the influence of nuclear power on various aspects of our lives, from science and tech to politics and safety. Let's start with the scientific realm. Nuclear power has been the driving force behind numerous technological advancements. It has led to breakthroughs in medicine, like radiation therapy for cancer treatment and the use of radioisotopes in diagnostic procedures. In space exploration, nuclear power has been the key to powering long-duration missions, contributing to our understanding of the universe. Moving on to politics, nuclear power has significantly influenced international relations. The delicate balance of nuclear deterrence has, in many ways, shaped the geopolitical landscape since the mid-20th century. Nuclear energy policies and regulations also have far-reaching implications for national security and international diplomacy. In the context of safety, while nuclear power has the potential for catastrophic accidents, stringent safety measures and technological advancements have significantly reduced these risks. It's crucial to remember that every energy source has its risks, and it's our responsibility to manage them effectively. But perhaps the most profound impact of nuclear power lies in its potential to address one of the most pressing issues of our time: climate change. As a low-carbon source of energy, nuclear power can play a significant role in reducing greenhouse gas emissions and slowing the pace of global warming. It provides a reliable, large-scale energy source that can complement renewable energies like wind and solar. However, it's not a silver bullet. The challenges of nuclear waste disposal, high upfront costs, and public perception remain to be addressed. Yet, with the right strategies and innovations, nuclear power can be a part of the solution to our climate crisis. So whether we realize it or not, nuclear power has a significant role in shaping our world and our future. And